Hello everyone, this is Mr. Zimmerman, and today we're going to start Chapter 8 by looking at Section 8-2. So let's zoom in at the box at the top of the page where it says what your objective is. And what it says in the box, it says I can. You're going to be able to use the tangent ratio, which is abbreviated TAN. You're going to use the cosine ratio, which is abbreviated COS, and you're going to use the sine ratio, which is abbreviated SIN. So the ratios we're going to be using are called trigonometric ratios, or just trig ratios, and they are formed by just taking the length of one side of a right triangle divided by the length of another side of that right triangle. And what you can do with them then is you can use these trig ratios to find the missing side or an angle in a right triangle. Taking a look at this figure now, we have a right triangle. We know that the two sides that form the right angle are called legs. And then the side across from the right angle is called the hypotenuse. That's the longest side of your right triangle. So in this diagram, with respect to angle A, which I'll mark for you right here, if you go across from angle A, what you're going to have is this side that I'm going to darken in red for you. That side is called the opposite side, because it's opposite or across from angle A. Then if I mark the right angle in this right triangle, across from the right angle will always be the longest side of the right triangle, or the hypotenuse. So I'm darkening that in blue for you. That is the hypotenuse. And then with respect to angle A, this third side that I'm darkening in green, that is the side that is adjacent to angle A. And these are the three sides that we're going to use to form our trig ratios: the opposite, the hypotenuse, and the adjacent. In this case, with respect to angle A. The next thing you can see we have here is it says SOH, CAH, and TOA. And we say that is SOHCAHTOA. Well, let's hold off on that for a minute, and I'll show you what that means. And let's go down here below that, and we're going to define what the sine of angle A, the cosine of angle A, and the tangent of angle A are. So what I've written down for you is that the sine of angle A is equal to the length of the side opposite of angle A divided by the length of the hypotenuse. So what we're going to write for that is we're going to write O over H. And that stands for opposite over hypotenuse. Then we have, for the cosine of angle A, that ratio is going to be the length of the side adjacent to angle A divided by the length of the hypotenuse. So for that one, we are going to write A over H, which stands for adjacent over hypotenuse. And for the tangent of angle A, we're going to have the length of the side opposite of angle A divided by the length of the side that is adjacent to angle A. So for that one, we are going to write O over A, which stands for opposite over adjacent. Well, now hopefully you can see where this, up here I have this thing that says SOHCAHTOA, right? So the first one says so, and what that stands for is the sine is the opposite side length divided by the length of the hypotenuse. So we would have the S, O, and then we would have OH. And then in the middle here, we have CAH, C-A-H. And what that stands for is that is the C from the first letter of cosine, and then A over H. So that gives us the CAH in the middle. That is the cosine is the adjacent over the hypotenuse. And then last we have this TOA, T-O-A. And what that stands for is that the T comes from the first letter of the word tangent. And then we have O over A, which means with respect to whatever angle we're looking at, it's the length of the opposite side divided by the length of the adjacent side. So we put that all together, and we have SO, CA, TOA, which is what helps us remember the definitions for the sine, the cosine, and the tangent ratios. So let's look at example 1. They want us to write down the 3 trigonometric ratios, the sine, the cosine, and the tangent of angle Y. So the first thing we want to do is set this up and label our sides with respect to angle Y. So angle Y is actually this angle right here. So across from that angle, this 84 here, this would be the length of the opposite. So I'm going to call that OPP. Then across from the 90-degree angle, so across from the 90-degree angle, we can see that the 85 there, that is the hypotenuse. And then this other side, the 13 here, that is the side that is adjacent to angle Y. That is what we really want to do in every single one of these trig ratio problems, is with respect to whatever angle they give us, in this case angle Y, we want to label the 3 side lengths as the opposite side length, the adjacent side length, and the length of the hypotenuse. Do that first every single time. And then we should be able to write down these 3 ratios now, and we're going to write them down as a fraction. And then we're also going to change those fractions into decimals that are rounded to 4 decimal places. So we're going to want 4 digits after the decimal point. So we're going to need a calculator to do that part. So let's write down our ratios. So the first thing we're going to write down is the sine of angle Y. And that is going to be the opposite, which is 84, divided by the hypotenuse, which is 85. Then let's write down the cosine of angle Y. That's going to be the length of the adjacent side to angle Y, which is 13, divided by the length of the hypotenuse, which is 85. And then we're going to write down the tangent of angle Y, which is the opposite side length, which is 84, divided by the adjacent side length, which is 13. Then all we have to do to finish this is it says we also want to write down these ratios as decimals rounded to 4 decimal places. So the sine was 84 divided by 85. So you're going to put that in your calculator and you're going to round off after 4 digits, okay, after the decimal point. So if we do that, we should get, for this one, we're going to get 0.9882. And then for the cosine, we're going to do 13 divided by 85 on our calculator, and we're going to get 0.1529. And then we'll do the tangent. And the tangent, this one comes out to be 6.4615. And there we go. That's all we had to do for this one, is just write down those 3 ratios. Let's take a look at one more example like this. So turn the page. I don't think we'll need to do parts B and C. So let's just take a look at part C. In part C, we're looking at this right triangle with respect to angle B. So let's mark that angle first. So I marked angle B. And again, across from angle B, that is going to be the opposite side length of 60. Then across from the 90-degree angle, we're going to mark or label this as the hypotenuse. And then this other side, the side length of 91, that is going to be the side adjacent to angle B. Again, this is our important first step in any of these right triangle trigonometric problems, is you want to talk about which angle you're looking at. So we're looking at this triangle with respect to angle B, and then you want to label these three sides as opposite, adjacent, and hypotenuse. So let's write down our three trig ratios. So the sine of angle B is going to be the length of the opposite side, which is 60, divided by the length of the hypotenuse, which is 109. And then the cosine of angle B, that is going to be the length of the adjacent side, which is 91, divided by the length of the hypotenuse, 109. And then the tangent of angle B is going to be equal the length of the opposite side, which was 60, divided by the length of the adjacent side, which is 91. And as a quick reminder of which sides I'm using in each of these ratios, remember the so, we had SOHCAHTOA, right? So the sine, that was the opposite over the hypotenuse, so that was the O over H. The cosine, that was the ka, that is the adjacent over the hypotenuse. And then the tangent, that was the toa, so that was the opposite over the adjacent. So again, we have so, ka, toa. Now all we got to do to wrap this one up is we got to convert these ratios into decimals again, and we want 4 digits after the decimal point. I should probably point out one more thing before I write down the decimal form of these ratios, is if you look your answers up in the book, they are going to reduce these fractions. So the 60 over 109, the 91 over 109, and the 60 over 91. But in this case, we can't reduce them, so we're just going to leave them like they are. But just watch for that, okay? They will reduce the fractions if you're going to look up the answers in the back of the book. So you should probably do that if you can. But in this one we can't, so I'm just going to write down the decimals. The decimal form for 60 over 109, that is going to be, using your calculator, 0.5505. And then the cosine is 91 over 109. That is going to be 0.8349. And to get the decimal form of the tangent, again, you're just going to do 60 divided by 91 on your calculator, and that is going to be 0.6593. Now let's move on to probably the easiest part of this lesson. So we're moving on to example 2. The directions for example 2 say to use your calculator to find each trig ratio. So all we have to do, and to round your answer to the nearest hundredth, so you're going to want 2 digits after the decimal point, then you're going to round off. So to do the first one in part A, to do the sine of 42, most of you guys have been using your phone as your calculator. So what you're going to have to do is, like if you hit the calculator on your phone, what you're going to get is just a basic calculator. But if you turn your phone sideways, then you should bring up the more advanced features of your calculator on your phone, and you should see the sine and the cosine and the tangent buttons that are available on your phone. The other thing you're going to need to do is all of these angles are given in degrees. So you're somewhere on your phone, you're going to have to look to make sure that the angles that you're going to type in are in degrees. So you're going to want to hit DEG, or I should say DEG on your phone screen. If it says RAD, try hitting that and it should change to DEG. All right, you want DEG for degrees. You do not want it in radians, which would be RAD. So when we do example 2, parts A, B, and C, I think that'll be good enough to do the first 3. You're going to need to put these in your phone calculator, or if you have your own calculator, type these into your own calculator and make sure you get the same answers that I'm getting, okay? Because that's really going to mess you up on the next section if you're not getting the correct answers for these. So you have to try these with me. Don't just write it down in your notes. You must actually try it on your calculator or on your phone calculator. So for part A, I typed the sine of 42 degrees into my calculator. And what I got is I got 0.6691. Now these directions say that we're going to round to the nearest hundredth, so we're going to need 2 digits after the decimal point. So we're going to round off right there. Since the number after the hundredth spot is a 9, remember if this digit is 5 or larger, we're going to round up. So on this one, our answer is going to be 0.67. In part B, I typed the cosine of 89 degrees into my calculator, and I get 0.0175. But again, I'm going to round off right here. So again, this digit is a 7, so if it's 5 or larger, I need to round up. So my final answer for this one then is going to be 0.02. Let's move on to part C, and I think that'll be good enough. So type tangent of 55 into your calculator or your phone. Make sure you're doing this with me so you're getting the same answers, okay? So on this one, I get 1.4281. And again, we're going to round to the nearest hundredth, so we're going to round off right here. This digit again happens to be a 5 or larger, so we're going to round up again. So for this one, we get 1.43. So that's our tangent of 55 degrees. I should probably quickly point out what this means when you get the tangent of 55 equals 1.43. What it means is if you draw any size right triangle, if you draw a perfect right triangle that has a 55-degree angle in it, if you measure the length of the opposite side and the length of the adjacent side, and you divide, okay? So if you take the length of the opposite side divided by the length of the adjacent side of that triangle, no matter how large or small that triangle is, as long as it's a right triangle with a 55-degree angle, the length of the opposite side divided by the length of the adjacent side will always be 1.43. So all of these trig ratio values, they're already programmed into your calculator, your scientific calculator, your graphing calculator, or into your phone. So let's go on to example 3 and then see how we use these trig ratios to solve problems. Let's look at example 3, part A. It says find the value of x. So we're going to find the length of this side right here. And it says to round your answer to the nearest tenth. So we're going to need 1 digit after the decimal point. So the first thing we have to do is we have to identify the angle we're looking at this with respect to. So the angle that we're given here, I'm going to mark, that is the 28-degree angle right here. So with respect to that angle, if I go across from it, we can see that x that we're looking for here, that is the opposite side length. And then the 15 at the bottom, that is going to be the adjacent side length. And then across from the 90-degree angle, we're going to have the length of the hypotenuse. So we always do that first. Mark your angle, and then with respect to that angle, label your 3 sides as the opposite, the adjacent, and the hypotenuse. So in part A, we're going to want to use the opposite side length because we're trying to find x. And we're going to want to use the adjacent side length of 15 because we know that one. It's given to us. So really in this one, we don't know anything about the hypotenuse. So we don't want to use the hypotenuse because that's not part of the information that we're given, or it's not the x that we're trying to find. So now what we need to do is we need to think about which one of the three trig ratios, either the sine, the cosine, or the tangent, which one used the opposite side length and the adjacent side length. So if you think of your SOHCAHTOA, it was the tangent that was the opposite over the adjacent. So we're going to use tangent on this problem. So we have the tangent of our angle. Well, in this case, our angle is 28 degrees. So the angle always goes right next to the trig function. Okay, in this case, the tangent function. So the angle always goes right here, right next to your trig function. And then we know that that's equal to the length of the opposite side, which is x, divided by the length of the adjacent side, which is 15. So just as a reminder again, the tangent was the opposite over the adjacent. So I'm going to show you a couple different ways to solve these. The tangent of 28 right here, that's in the numerator, so really we could put this over 1 if we wanted to. And then the other thing that you guys can remember is up above, when we're just typing these into our calculator and getting the answers, is this thing right here, the tangent of 28, that is just a number that you can get off your calculator, right? I said for any right triangle that's drawn perfectly with a 28-degree angle, if you divide the length of the opposite side by the length of the adjacent side, you're going to get that decimal number off of your calculator. So let's get this decimal number off of our calculator, all right, or our phone. We want to type in the tangent of 28 degrees. So for the tangent of 28, I type that in my calculator, and I'm going to round this off after 4 decimal places, okay? So 4 digits after the decimal point. That's going to give me 0.5317. That's the tangent of 28 degrees. I'm going to put that over 1, and that's going to equal x over 15. Well, now I think you can see, just like when we were in chapter 7, we're just going to solve this proportion by using cross products. So our first cross product is going to be 1 times x. Well, that is just x. So I have x is equal to our other cross product, which is 15 times 0.5317. So 15 times 0.5317. Which gives us x equals 7.9755. But again, we're supposed to round our answer to the nearest tenth. So we're only going to keep 1 digit after the decimal point. So we're going to round off right there. And again, the next digit after the 10th position is a 7, which is 5 or larger. So we're going to round up. So if we round this one up, that 9 needs to round up, and we're going to get x equals 8.0. Well, let's move on and do part B. In part B, we're going to label our sides this time with respect to our 56-degree angle. So across from the 56-degree angle, we have an opposite side length of x. And then across from the 90-degree angle, we have a side length of 9. That would be our hypotenuse. And then we have this adjacent side that is adjacent to the 56-degree angle. Well, again, if you look at this one, we're given x, or I should say we're given 9. So we're going to want to use the hypotenuse. And we're trying to find x, so we're going to want to use the opposite side length. We don't know anything about the adjacent side length, so we're not going to use that one. So then we have to look back at our SOHCAHTOA, and we have to decide, well, which trig function, either sine, cosine, or tangent, which one uses the opposite side length and the length of the hypotenuse. And for that, if you think about it, that would be OH, So that would be so. So it's the sine that we need. Then we're going to write the sine of our 56-degree angle is equal to the length of the opposite side, which is x, divided by the length of the hypotenuse, which is 9. And again, I'll remind you that the sine was the opposite over the hypotenuse. At this point, you could type the sine of 56 degrees into your calculator or your phone and then get a decimal for that. Again, I was using a decimal with 4 digits after the decimal point. But this one, I'm going to do it slightly different. So let's try it this way. So what I'm going to do is, first of all, I'm going to put the sine of 56 over 1, and then I'm just going to do my cross products right now, just the way it's written. So my first cross product here would be 1 times x. Well, that's just x. And then my other cross product is the sine of 56 degrees times 9. Or I could write it this way, 9 times the sine of 56 degrees. And then I'm just going to type this into my calculator just like I've got it written right here, and that will give me my answer. I typed 9 times the sine of 56 degrees into my calculator, and I got x is equal to 7.4613. But again, the direction said round off to the nearest tenth, so I'm going to round off right here. And again, the digit after the tenth position is 5 or larger, so I'm going to round up. So for this one, then my final answer is going to be x is equal to 7.5. A couple quick comments here. First of all, well, let me circle my answer. But the comments I'd like to make is if this 9 had units given on it, like if it was in feet or meters, then your answer would be either, 7.5 feet or 7.5 meters, okay? And the other thing is, when you get your answer, you should look at it, and you should say, does this side length of 7.5, does that make sense here for this leg on this right triangle? So 7.5 units or 7.5 units. And I think that makes sense because the hypotenuse would be the longest side on this triangle, on this right triangle. And you can see that that's 9 units. So this would have to be something less than 9 units for this leg. And, so if you get some huge number, or certainly if you got a number larger than 9, then you made a mistake. Okay, because the 9 would be the longest side on this right triangle. I think we're just going to do 3 of these. So let's move on to D. So we're going to move on to part D. And if you guys want to try part C and E and F on your own, I always post the notes answer key, and you can try them on your own, and then you can take a look at the key when you're in Schoology and check and see if you got the answers right for those other 3 parts. But for now, let's just focus on part D and wrap this up. In part D, we're going to label our sides on our triangle with respect to this 61-degree angle. So across from that, we would have our opposite side length. And then across from our 90-degree angle, we would have the length of our hypotenuse, which is x. And then this other side, length of 15, would be the length of our adjacent side, the side that's adjacent to the 61-degree angle. So for this triangle, we're going to want to use this side length of 15 because it's given. And we're going to want to use the hypotenuse because we're trying to find x. All right, so we're really not going to use the opposite side on this one. So I'm going to erase that because we don't know anything about that side. So now we have to think about which one of our trig ratios, either the sine, the cosine, or the tangent, uses the adjacent and the hypotenuse. So if you think about that for a second, that's AH, adjacent and hypotenuse. So that was the cosine. So for part D then, we're going to use the cosine of our angle, which is 61 degrees. And that is going to be the length of the adjacent side divided by the length of the hypotenuse, which is x. Take note that this one's a little bit different because in this one, the x that we're trying to solve for, the length of the hypotenuse, it's actually in the denominator of this fraction. But I think we'll deal with that just fine. It shouldn't be an issue. So let's go ahead and put the cosine of 61 over 1, and let's do our cross products. So the first cross product I'm going to do is I'm going to do x times the cosine of 61. So I write x times the cosine of 61 degrees. That's going to equal my other cross product, which is 1 times 15, or just 15. To finish solving for x on this one, I need to get the x all by itself. So I want to get this by itself. Well, because I have this multiplication right here, I'm going to divide both sides by the cosine of 61 degrees. These will cancel out on the left-hand side because the cosine of 61 divided by the cosine of 61, well, anything divided by itself is 1 and it cancels out. So I just get x, or 1x, is equal to 15 divided by the cosine of 61 degrees. And now I just have to type this in my calculator and I will have my answer. And I get 30.93. But again, we're going to round off to the nearest tenth here. So we are going to round off right there. And this time, since this number is less than 5, I'm going to leave the 10th digit alone. So my final answer on this one then is going to be x equals 30.9. All right, so that's the length of my hypotenuse on part D. And that's going to wrap it up for section 8-2. As always, you guys, thanks for watching, and I'll see you soon in class. Thanks, bye.